Hello, math champions. In this video, we're going to learn about polygons and their interior angles. If you have not learned about what is polygons, go click on the right top corner. There's a link there. Go ahead and first learn what is a polygon. And because if you don't understand that, you're not going to understand this. So always math goes upon the foundations. Okay, assuming or confirming myself that you have learned about what is a polygon, what kind of figures are called polygons, what are the different types of polygons, what are the names of it, and all those things. After that, after knowing that you know all of those things, now we'll talk about the next topic called the interior angles. I've already mentioned to you in the other videos, interior angles means inside. So basically, I've drawn many polygons here already. So the angles inside them, right? This angle, this angle, this angle, the inside is called as the interior angles. That's all. And if you see, I have taken different types of polygons, four-sided, five-sided, six-sided, seven-sided, sorry, eight-sided. All of these things I have taken. Okay. And we know the names of it also. We're going to write. And also, I have taken regular polygons. Regular polygons means what? All the sides are equal to each other. Okay, that kind of thing is what I've taken. But however, you can take irregular polygons also. That's not a problem here. Okay, and one more thing, I have taken convex polygons. That means all the interior angles are always acute or obtuse, but not reflex. Okay. So these polygons I have taken, important is I have taken, they're all convex polygons. Okay. That is one of the things that you have to understand. Okay. Now let's talk about various different interior angles. Interior angles means that's all. The simple is inside. So let's go ahead and talk about different interior angles. And first, let's name these things. Okay. So the name here is a square or a quadrilateral. This is a pentagon. This is a hexagon. And this is a octagon, 8-sided. I have not written heptagon. Okay. 7-sided. So this has 4 sides. This has 5 sides. This has 6 sides, and this is 7 sides. So the number of sides is this much. Now, I wanted to notice something, interesting. Any of these polygons, they can be cut into triangles. Okay, triangle is the basic polygon. See, this triangle is a basic polygon because this has 3 sides and lesser than 3, 2. You cannot make a polygon using 2 sides. It's not possible. So basic, the minimum number is 3. So however, I've started here with the 4-sided figure. And there's a reason for it. I will explain that in further videos. However, let's say I've taken start 4, 5, 6 and everything. And the beauty is any polygon, okay, can be cut into triangles. So see, this one I was cut into this triangle. Now next, here I am going to cut into triangles like this. See, these lines are not intersecting basically, okay? They're not intersecting, but basically this full figure is made into different triangles. If you can see, I have made it into triangles, right? So here is one triangle, here is one triangle, and if I draw like this, one more triangle. There's no crisscross, nothing between, they're not diagonals as such, remember? It could be triangles, it may not be triangles. Basically, I'm cutting this entire thing into triangles. And yeah. Okay, so let me do this triangle here, 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 and here. And I get a square inside, which I make in another. Okay, so I have made triangles. Now let's find out, let's count how many triangles was I able to make. Okay, how much triangles I was able to make? I was able to make 2 triangles. Here I was able to make 3 triangles. Here I was able to make 4 triangles. Here I was able to make 1, 2, 3, 4, 5, 6. 6 triangles. Okay. Do we see a pattern here? Do we see a pattern here? See, if you see 4 minus 2 is 2, 5 minus 2 is 3, 6 minus 2 is 4, 7 minus, okay, how many, sorry, this is not 7, it's 8, right? Octagon means number of sides is 8. Okay, number of sides 8. 8 minus 2 is 6. Right? So this pattern is same. Number of triangles is same. Oh wow, it's nice pattern is coming up. Okay, now because we know inside one triangle, we've already learned by the angle sum property that the inside one triangle, this angle plus this angle plus this angle is equal to 180 degree. Right? So this three angles are joined together, give me 180 degree. Similarly, if I take this and this is going to give me a 180 degree. See, I'm writing 180, but it's not actually like it's in the centers or it's the area and all. Understand? It's this addition of these three things is 180 basically. So in that sense, if you see, if I have to write the sum of interior angles, what I can do? What I can do is interior angles. Wow, I have two triangles. I have two triangles. So number of triangles into 180. Right? Number of triangles into 180 is going to give me that. Similarly, if I have to find all the interior angles, this entire interior angle means there's one part here, one part here, one part here. Okay, one part here, one part here. If you see, all these angles join up to make the triangles of all the triangles. So this is 3 times 180. And this becomes 4 triangles of 4 180s. And here is going to be 6 times 180. So the sum of the interior angles of these polygons are all coming in this fashion. So can we come up with a general formula, because we're seeing a pattern. That's what we learn, right? When we see a pattern, we come up with a formula. So if a polygon is having n sides, the number of triangles it forms is n minus 2, and therefore the sum of the sum of the interior angles will be this n minus 2 multiplied by 180. So this is our expression for sum of interior angles of any polygon. So if a polygon is having n-sided polygon, okay, then the sum of interior angles, sum of all the angles inside that polygon will be equal to n minus 2 times 180. Okay, n minus 2 times 180. You can use like this. Now, okay, now number of polygons, sum of interior angles, this is for all kinds of polygons. It could be regular or irregular or anyhow it is going to be, this is going to be true. This is going to be true. Okay. If you add up all the angles inside that polygon, and remember, these are all convex polygons, okay? Convex polygons. They are not concave polygons. Okay, now coming to, if I have to find one interior angle, okay? Now, if all the sides are equal, only then I can say all the angles are also equal. That means if it's a regular polygon, second, if it's a regular means all the sides of the polygon are equal. If all the sides are equal, regular polygons, all the angles also will be equal. All angles will be equal. If all angles are equal, okay, if it's a n sides are there, means there's going to be n angles. And all angles are equal. So in a regular polygon, one interior angle can be found out by what? We know sum of the interior angles. Sum of the interior angles by n. That means to say that because it's a regular polygon, all the angles are equal because the sides are equal. And because all the angles are equal, we just take the summation. Like we already found the sum of the interior angles n minus 2 times 180 divided by n. So we'll get the one interior angle. Example. Now if I have a pentagon, regular pentagon, if they say what do I know? It's a regular means it is all the angles are equal, and pentagon means n. The number of sides is 5. So one interior angle of this pentagon will be how much? Let's find out. Okay. What is it going to be? 5 minus 2. That means 3 triangles I can form. 3 triangles means 3 180s. And every angle means by 5. So 3 times 180 over a 5. Okay. So 3 times 180 over a 5. That's what is going to be there. And this is going to be 3, 6. So it's going to be 108 degree. So one angle of a regular pentagon is 180, 108 degree, 108 degree, 108 degree. It's going to be there. That's what we have found. Like this, for any number of sides, the polygon, you can find out easily. So a quick recap of how we found out the interior angles. See, why am I showing you all how we found and all is because even if you forget this formula, you will know, okay, it's a hexagon. You will draw a hexagon. You will cut it into triangles. You can say, okay, this has this many triangles. One triangle is 180 degree. That means this many triangles is this many degrees. Okay, I got all the, all the angles, interior angles. How much is it I got? Now I have to find out one angle. That means if hexagon means 6 angles are going to be there. I know the sum. I have to just divide it. See, even without the formula, you will be able to do that. That's the reason I'm showing you all of these things. Okay, of how it is coming. Otherwise, yeah, you can just take this formula. Okay, you can just copy or mug up this formula and then try to remember, and then you might forget. All those things happen. Instead, math champions learn how, why, and everything, right? Okay, so we're talking about polygon and then interior angles. Interior angles means inside. So whatever kind of polygon it is, we can cut it into different triangles. So once we cut that into triangles, we know every triangle, the sum of angles is 180. So number of triangles multiplied by 180 is going to give you the sum of the interior angles. And generally, if n is a number of sides in a polygon, then n minus 2 number of triangles are going to be there. Okay. N minus, see, even if you take a triangle has 3 sides. 3 minus 2 is 1. That means one triangle, right? So that also applies from there also it comes. Okay. So if there are n sides, then n minus 2 triangles are there. And n minus 2 times 180 is going to give you the sum of the entire interior angles. And if it's a regular polygon, that means all the angles are equal. Then just dividing by the number of sides n is going to give me one interior angle. Quick recap is also done. Go ahead and try to solve some problems on this and master the concept. I'll see you in the next video and we'll talk about exterior angles, means outside the polygons. I'll see you in the next video. Until then, bye-bye.